Hey guys, in this video we will discuss the questions of June 2012. So let's see the first question here. So this is question number 7. Okay, in the last video we have done up to question number 6. Okay, so here it is said consider a system of non-interacting particles in d dimension obeying the dispersion relation epsilon is equals to a k to the power s, where epsilon is the energy, k is the wave vector, and s is an integer. A is representing a constant. So density of state denoted by n epsilon, okay, as a function of energy, it is proportional to what? So if you have seen in the last video also, we have done a question related to density of states, energy, and the wave vector. So you know the density of states, it is generally denoted by this also, but here it is given Ne, so it is proportional to what? Energy epsilon or E, whatever it is, to the power d by s minus 1, right? This is what is this is general form, and this is a very easy question. So directly you can see the correct option is option B. Next, let us see the experimentally measured transmission of metal, insulator, and semiconductor thin films are shown in the figure. So this figure is showing the experimentally measured transmission of metal, insulator, and semiconductor. So it can be inferred that 1, 2, and 3 corresponds respectively to what? So you will have to tell which curve is for metal, which is for insulator, and which is for semiconductor. Okay. So this is between wavelength and transmission. So you see, when we are discussing about transmission, okay. So in case of metal, okay, it is not depending upon the wavelength. Okay, you will have to remember transmutation of metal. It is not depending on metal. So therefore, what will happen? There will be what? No transmission. Okay, from metal there will be no transmission. So if you see this straight line, it represents the metal. Okay, this is for metal. Next, you see, now we are having semiconductor and insulator. Now you see, when we are looking for semiconductor, due to doping, transmission is what? Greater than insulator. This is the theory part. Okay, in semiconductor, the transmission is greater compared to what? Insulator. And why it is so? Because of doping. And this for more details you go and see, but this I'm just giving you the basic detail. So you can see here which curve will represent the insulator, the first one, and the second one will represent semiconductor. Okay, in this case, so what will be the option? The first is, this is metal, third is metal, right? Okay, this second one is semiconductor, and the first one is what? Insulator. So the correct option is option A. All right, now let's see the next question. In question number 9, it says the energy required to create a lattice vacancy in a crystal is equals to 1 electron volt. The ratio of the number densities of vacancies, okay, at 1200 Kelvin by 300 Kelvin when the crystal is in equilibrium at 1200 Kelvin and 300 Kelvin respectively is approximately what? So you are asked to calculate what? The energy required to create is given to you 1 electron volt. Okay, to create what? Lattice vacancy in a crystal. Now you see, you will have to calculate the ratio of number densities of vacancies for this. Okay, and when here it is said the crystal is in equilibrium at these two temperatures. All right, so we know the Scott effect and the vacancy defect. So from there we can write the number density formula. Number density n, it is equals to what? Capital N e to the power minus e by 2k bt. So the notations we know is the energy required for vacancy formation, right? So E is the energy required for vacancy formation. Okay. Next KB, you know it is the Boltzmann's constant. It is the Boltzmann constant. Next T, it is the temperature. Okay, it is the absolute temperature. Okay, and N, it is the concentration of or atom. Okay, it is the concentration of atoms. So let me write here. N is the concentration of atoms. Okay, done. So you can write capital N, it is equals to, you have already seen small m, Na, this is the Avogadro's number, this is 2 kb T, this is what you can write. Okay, here m is the mass and capital M is the molar mass. These things are very clear. Okay, so directly we will write what? N1 and N2. Okay, here N1 is denoting, I'm taking it to be N1 is written as this N 1200 Kelvin, and 2 I'm writing to be this N 300 Kelvin. Okay, so finally how you write N1 by N2? It is equals to e to the power minus. Okay, energy E, it is same for both, so I'm writing it E. Okay, now E, okay, 2 kb Boltzmann constant is there. Okay, 2 kb divided by T1. Okay, and here you will write what? Small e minus e 2 kb T2. Okay, this is what we are writing. Now you see here, this is what? N 1200 Kelvin, this is N 300 Kelvin. Just put the values in this case. So this will be 1. Okay, so I'm not writing it. Again, when you would take this to the numerator, it will be what? E to the power. I'm just writing it once again. Okay, 1 by 2 kb T1. This will become plus 1 by 2 kb T2. Now when you will take common, okay, when we will take common 1 by 2 kb. Okay, this is what? 1 by T2 minus 1 by T1. T2 and T1 value you know, right? It is what? T1 is here 1200 and T2 is what? 300. So just put the values e to the power minus 1 by 2 kb, and here you will write what? 1 by 300 minus 1 by 1200. When you will solve this, you will get e to the power minus 1 by 2 kb. Here you will get 1 by 400. Just calculate and see. And when you will do the entire calculation, you will get exponential 30. Okay, plus 30, positive 30. This is what you will get. The calculation part I'm not doing. You can just use calculator and do it. Okay, so the correct option is option D here. Next, let us see question number 10. Here it is said the dispersion relation of phonons in a solid is given by omega square k. It is equals to omega naught square into with 3 minus cos kxa minus cos kya minus cos kza. The velocity of the phonons at large wavelength is what? So dispersion relation is given to you. You are asked to calculate the velocity of the phonons at larger wavelength. So this you can just do d omega by dk, right? This is how you can do. So first you see what is given to you for this, and you know for larger wavelength you will ignore this. You know, let me write here. For larger wavelengths, okay, we know that kxa, kya, and kza for larger wavelengths, it is very, very small than 1. If you have read the theory, this will be very easy for you. Directly you can attempt. When it is talking about larger wavelengths, again, these are shorter wavelengths, just see the conditions. Okay, then now you see in question it is there omega square is equals to what? Omega naught square, right? Here you are having what? 3 minus cos kxa. So you know what is cos x? 1 minus x square by factorial 2 plus x to the power 4 by factorial 4 minus and so on. So here you will write what? 1 minus, okay, kx square by x square by a square by 2. Higher order terms we are ignoring. Okay, for larger wavelengths here. So minus this will be what? 1 minus k y square a by 2. Okay, minus 1 minus k y square z, so k z square a by 2. Okay, this entire term. So if you see this is minus 3, so it will get cancelled and you will have here what? Omega naught square, right? And here you will have what? This is also kx square. This is a negative sign, so it will be what? Kx square, right? And everywhere a square is that, so take it common 2 also, and you will have what? Plus k y square plus k z square. This is what this is what? This is nothing but k square. So you can write omega naught square a square by 2. This is k square. Now this is omega square. Okay, so from here you can write omega is equals to what? Omega naught a k by root 2. Okay, and you will do d omega by dk. Okay, so d omega by dk. So if you see here, you will get omega naught a by root 2. Okay, d dk of k. Then, so omega naught by root 2 is the omega naught a by root 2 is the correct option. That is option D. Done. So directly you can put the values. Okay. All right. So this is how you can calculate. For solid state physics, if you know the theory well, if you know the formulas if you know the conditions very well, and if you can derive from one formula to other, if you can connect, okay, then all the parameters, if you know it well, it will be very easy for you to solve the question. And I would request you, whenever you are solving solid state questions, mainly read the question 2 to 3 times. All right. So that's all in this video. Thank you so much. Have a good day.